Hi everyone. We're gonna analyze our jet electrophoresis research using imagej. It's a really handy tool that helps us measure and interpret images accurately. And search for imagej on Google and click this website and click download. And click the link for Windows, then it starts downloading. Yeah, after downloading, you can see this folder. Double click it and double click this folder. Then you will see this file. Then double click it and extract all. Yeah, extract. Yeah, now double click this folder and then click this file, imagej. Then you will see this window, then we are ready to start imagej. Click File, open, select your image. Then click on the rectangle tool and select the area you want to analyze. Then go to Image, Crop. If you press Ctrl and scroll down, you can zoom out to make the image smaller. Next, go to Image, Transform, Rotate. We need to make sure the lanes are nice and straight. So you can turn on the grid to help you line things up and then adjust the rotation angle until it looks straight. But this image is already straight, so I didn't need to adjust it this time. Next, go to Image, Type, and click it to change the image to black and white. Now we will make it a bit clearer. Just adjust the brightness and contrast. Then click Apply. This is just an example, so I will use only this small section, but you should use the entire area. Then we are ready to start measuring. So first we need to compare the sizes using the DNA ladder. So open the image I uploaded on Blackboard. Yeah, this image. So we will use this one to compare. And then go to Analyze, Tools, ROI Manager, and place here. Okay. And as you can see, the letter bands in this image are a little blurry. So try your best to identify each band carefully. Like it should be 100 base pair, 200, 300, 400, 500, 6, 7, 8, 9. It's pretty hard to tell the differences between 900 and 1000 base pair. So we will probably only measure up to 900 base pair, but that depends on your data. Okay, so when you measure, click this one and then start right here. Yeah, the y value should be 0. Then click and hold shift to draw a perfectly straight vertical line. And then click at the bottom of the band, like that. So after that, click add, and then click this item and rename. It should be 100 base pair. Okay, and then we will repeat this. For 200, click here. You can see the y value over here. Okay, and shift. Okay, and add, click it, rename, and 200 base pair. So we cannot undo in this imagej, so make sure carefully to measure. And then click show all and labels. Then you will see these results. Okay, then I will repeat it. Now I'm going to measure our samples. In this example, I only have one band, so this one will be labeled A1. If your result has several bands, make sure to measure all of them. Okay, and then this one will be labeled B1. Right, now we are going to measure the length. Just click on the item you want to measure, then click measure. And then repeat this. Next, we are going to save the file. Make sure to save it as an Excel file, so we can use it for data analysis later. This is our data file, and we are going to create 3 new columns: relative migration, base pair length, and log 10. For the relative migration, select the length cell and divide it by the first cell, which represents the 100 base pair band. Now type in the base pair size of each sample. From this point, we are going to calculate the DNA size of our samples later. And then take the log 10 of each DNA letter's base pair size. Then now we are going to create a graph using relative migration and log 10. To insert and create this scatter plot. And then we're gonna add trend line and this equation. We will use this equation to get the log 10 value. And using the log 10 value, we can calculate the base pair length. It's 10 to the power of log 10 that gives us the DNA size. Now let's compare it with the image. This one is 900 base pairs, so we can tell that our sample is larger than 900 base pair.